Want to build an epic large-scale scene the easy way with Gaea and Unreal Engine? Hello everyone, Waving Hand. In this tutorial, we're going to create a massive game level inspired by the Danjiangkou region Sunrise Over Mountains video game. Get ready to bring a real-world environment to life inside your game engine. We'll start by using Gaea nodes to quickly build the base terrain. Then, we'll move on to creating masks for different landscape elements and exporting them for use in Unreal Engine. Then, we'll import everything into Unreal Engine and use the masks to build a fully automated landscape material, giving our terrain a professional and dynamic look. Next, we'll use those same masks inside the PCG system to automatically generate vegetation and natural coverage across the terrain. And in the end, we'll achieve a stunning, large-scale game level just like this. Alright guys, just like we said, we're kicking things off with Gaea. First, we bring in the node ridge, and after tweaking the scale a bit, we end up with this awesome result. Next, by adding the blur node, we make everything smoother. The next node we add is adjust, and by tweaking the multiply and clip settings, we can easily get closer to the result we're aiming for. Next, by adding the Hillify node, we soften the sharp edges of our surfaces a bit. To get even better detail, we also add erosion to them. Next, by using the lake node, we can add water to the scene. As you can see, our scene is now looking very close to our reference. Now it's time to create the masks. To do this, we'll try generating a mask from our islands. So we add the height node, and finally, the Hillify node gives us a much better result. Next, we make a copy of our height and reduce some of its edges near the water, since these areas are where the trees will be placed. As you saw, we export the islands, water, trees, and erosion, and by clicking the Build Mask option, we generate them. I changed the output format to 16-bit PNG. Now it's time to move into Unreal. We create a new scene in the vehicle template, since the map is quite large and we want to be able to drive around it in the end. Now we create a new level and switch to landscape mode to import our map. For the landscape, we use the erosion mask so that all the generated details are applied to it. After creating the landscape, as you can see, the scene isn't visible because the fog level is too high, so we lower it. Next, you'll notice that the amount of elevation doesn't match the height map we created, so we rebuild the landscape and change the Z-scale value to 150. After building the landscape, we move on to creating the material. First, we make a simple test material and switch it to material attributes. Then, we add a landscape layered material, give it 4 inputs, and rename them accordingly. Next, we create 4 Make Material Attributes nodes and connect them to the inputs. Now, we download 4 materials from Quixelbridge and add them to the project. For testing, we assign the albedo of each one to its corresponding material. We create an instance of our material and assign it to the landscape. Go into landscape mode, click the plus icon on each material layer, and select Weight Blended Layer. Now go to the Manage tab. Enable all the materials from the Layers section and assign the corresponding mask to each one. Finally, click Import, and just like that, the materials are applied to our scene. Now I want to take the material one step further. So we use a landscape coordinate along with a color node. Which will convert into a parameter. Then, we rename the channels to scale, normal, and height. We multiply these two together and connect the result to the UVs of each of our textures. Next, we connect our normal parameter channel to a flattened normal node and also plug the normal texture into this node. Finally, we connect the R channel of our last texture to roughness, the G channel to ambient, and the B channel, after multiplying it with our height parameter to displacement. Make sure to name each parameter properly so you can easily control all the textures. Now, just like in the previous video, we fixed the texture tiling issue using the same method. If you're not familiar with the texture variation method, make sure to watch the previous Gaea to Unreal video, where I explained in detail. Next, add a texture variation node to all the textures so they don't have any repetition issues. Now let's move on to PCG. First, save your work, then go to the Plugins section and enable it. Next, create a PCG graph and add it to the scene. This time, I'm going to make the size smaller so you can practically see what the mask does for us. I import the tree mask and add a Get Texture Data node, then assign the mask to it. To generate points on the surface, I use a projection node along with a Get Landscape Data node. To keep the scene lightweight, at this stage we use a density filter and noise to reduce the number of points. To add some variation, we also include a transform node and adjust the position, rotation, and scale values. Now we increase the size and match the mask with the scene. Now we reduce the number of points again so we can apply trees to them. As an example, we download a free tree from FabMarket and assign it to the static mesh spawner. Because the tree is quite heavy, the scene has slowed down a lot and might even crash the system. So, we either need to reduce the number of points, which would make the scene look less filled, or use a different tree. I prefer adding the European hornbeam asset to the project because it has high quality and includes lighter tree models. As you can see, we assign one of the trees from this collection, which also comes with animation, to the setup, and the result looks much more stylish. To keep the video from getting too long, we use the water material from the Rural Australia asset. We create a large plane and assign the water material to it. Now we can add a camera to the scene and place it wherever we like. We change its type to DSLR to get a better view. Now I want to make the PCG setup denser to achieve a richer scene. To do this, we use a Create Point Grid node. And with the help of the original points, we use a Copy Points node to generate additional points around them. Because the generated points are quite large, they're not easily visible. So, in the Copy Points node, we change the scale mode to absolute. Then, in the Create Point Grid node, we set the grid extents to 100 and decrease the cell size to increase the number of points. Now we add a Transform Points node to give the points different variations. Then, by adding a static mesh spawner, we generate plants around our trees. Next, you can add meshes like rocks or fallen tree trunks to your scene. If a new meshes overlap after adding them, you can use a difference node in binary mode to subtract them from each other. The area near the shoreline looks a bit empty. We can go back to Gaea, use another height map, and adjust the range to create detailed coastline lines. Now we can use the new mask in PCG, connect it to a Get Texture Data node, and assign any meshes we like to it. To make the scene look nicer, I download a boat from Sketchfab, and I'll share the link with you as well. In the camera settings, under the reflection section, I enable lumen and also turn on the high quality translucency options to get better water quality. You can also add a post-process volume, and after enabling infinite extent so it affects the whole scene, use the midtones and global settings to give the scene a bluish tone. If you want more variety of trees, you can simply add another option to their static mesh and assign a different tree. Thanks for watching this video. If you enjoyed it, don't forget to like, subscribe, and support the channel so I can make more content like this. Part 2 is coming very soon, so stay tuned.